Today's class is on potential energy of an electric dipole in an electric field. First, we have to know what is potential energy. First, I give the definition of potential energy. The potential energy of an electric dipole, potential energy of an electric dipole in an electrostatic field is defined as the work done, defined as the work done in rotating the dipole from zero energy position to the desired position in the field. First, the electric potential of an electric dipole in an electrostatic field is defined as the work done in rotating the dipole from zero energy position to the desired position in the electric field. Now I have to calculate the equation of potential energy in electric field. The force, the torque acting on the electric dipole, that is tau equal to Pe sin theta. Torque acting on the dipole, that is tau equal to Pe sin theta. For small angle d theta, for small angle d theta, the work done is dW. So dW equal to tau d theta, so Pe sin theta d theta. Now that is dW equal to Pe sin theta d theta. Now we have integrate, that is 0, that is theta 1, that is W, that is theta 2. Then W equal to Pe minus cos theta, that is theta 1 to theta 2. Then W equal to, we can write, that is Pe cos theta 1 minus cos theta 2. That is U, that is PE cos theta 1 minus cos theta 2. This is the equation of potential energy. Now we have put some conditions. First that is condition 1, that is theta 1 equal to 0 degree, theta 2 equal to 180 degree. We can easily calculate, that is U equal to PE cos 0 degree cos 180 degree, that is 2PE, that is U equal to. Condition 2, that is theta 1 equal to 90 degree and theta 2 equal to theta. Then W or U equal to, we can write PE, that is cos 90 degree cos 0 degree cos 90 degree cos theta degree, so that is minus PE cos theta, so U equal to minus P dot E. So we can easily calculate the equation of potential energy. Now from this equation we can easily get the relation, the equation of, that is potential energy. Now with the help of this equation we can get, that is we can get the we can solve the numericals. I have calculated electric potential energy of electric dipole in an electric field. With the help of equation of potential energy we can easily calculate different types of numericals. First numerical, here U equal to PE cos theta 1 minus cos theta 2. Here theta 1 0 degree, theta 2 that is 90 degree. So E equal to, that is PE. P, that is 2LQ. 2L, that is 0.01 into 5 microcoulomb, 5 into 10 to the power minus 6 coulomb meter. That is E is supplied, E is given. So putting the value of these two factors, that is P we can easily get the value 15 into 10 to the power minus 5. So the amount of work done is 15 into 10 to the power minus 5 joule. Second numericals, calculate the amount of work done in turning the dipole through an angle of 180 degree. If an electric dipole of moment 2 into 10 to the power minus 29 centimeter It is lying in equilibrium position in an electric field of strength 1.2 into 10 to the power 4 volt per meter. So from the equation we get U equal to 2PE. Since it is deflected towards the 180 degrees, so equation that is 2PE. So E equal to 1.2 into 10 to the power 4 volt per meter, and P2 into 10 to the power minus 29 kilometer. So putting the value 2 into 1.2 into 10 to the power 4 into 2 into 10 to the power minus 29. So U equal to that is 4.8 into 10 to the power minus 25. Hence the amount of work done is 4.8 into 10 to the power minus 25 joule. So these two numericals are easily solved. Basic thing is that first theory is playing a vital part for solving different type of numericals. I think all students will be benefited from my lectures, from my classes. Please subscribe my channel and watch my all video. Thank you all the students. Thank you.